think what would happen if I multiplied this times this. So let's do that thing. We end up with R1 times R2 times the cosine of A times the cosine of B. That's the first term. The next term is going to be R1 cosine A times I R2 sine B. R1 times R2 cosine of A. Oopsie, don't forget your I, Rob. Sine of B. And then let's put an I out here. Okay, is everybody okay with that? I think I got that. Thanks, John. There we go. So this is the first times the first, and the first times the second. Okay, and now I'm going to do the second times the first and the second times the second. So when I do this one times this one, it's going to be, let's go like this, I times R1 sine of A. Oopsie. That's not how I've been doing it. R times R1 times R2. And then the sine of A times the cosine of B. Okay, that's this one times this one. And then the last one will be this one times this one. And instead of writing I squared, I'm going to write negative. Because I squared will just be negative 1. So I'll subtract instead of writing I squared. So it's going to be negative R1 times R2 times the sine of A times the sine of B. Big mess. But I can still gather some like terms together. I can pull an R1 times an R2 out of the whole mess. See that? So I'll pull an R1 times an R2 out of it. I'm going to put a big set of parentheses in. Oopsie, I'm going to run out of space with that set of parentheses. I'll just leave it open. And then I'm going to think about the real component first. So the real component is going to be this part and this part. Does that make sense? I've pulled out. So I'm going to have cosine. I'm going to just skip my switching. Cosine A, cosine B. Subtract sine A, sine B. Does that make sense? And then, oopsie, don't close your parentheses yet. The imaginary part is going to be this cosine of A sine B. And then this part here, plus sine A cosine B. Now, in trig, there are some identities. And one of the identities is that this mess here is equal to the cosine of A plus B. And this mess here is equal to the sine of A plus B. And we got R1 and R2 still up front. And the proof of this thing is on that little thing, it's that little crazy looking thing that I got here. You can, if you want to try to recreate that for yourself, that's a pretty nice proof of it. I was happy to find that. I need to pull myself back a little bit because I'm running out of room. Can everybody follow all my scribbles? And you guys should yell at my scribbles go off the screen like that. I count on my classes to do that every day. Okay. Point taking this thing and multiplying by this thing that has a magnitude of R1, and this one that has a magnitude of R2, allows me to eventually write it as something with a magnitude of R1 times R2, and the angle is just the sum of these two angles. Kind of a sweet looking little thing. So this kind of way of talking about these things is pretty handy for that. It's so handy that we call the, I guess it's a version of the polar form of these things, where instead of talking about the components, instead of talking about the rectangular components, we're talking about the angles and their magnitudes. Okay? So we have these kind of things, and I guess I've kind of proved this one to some extent. That multiplying complex, the angles are added and the magnitudes are multiplied. All right. What does this do? I don't know. One of the cool things. Let's see if I can move to cool things now. One of the things that wilded me out when I first ran into it is this idea about all the roots of -1, or the roots of +1. Sorry, the roots of 1. I thought this was very interesting. Here is the unit circle imposed on this thing. Remember that if I multiply complex numbers, the angles are added and magnitudes are multiplied. So if I have a bunch of numbers, if I have a couple of numbers that are multiplied by one another, like this. We'll think about that as 120 degrees, 3 pi over 2. 2 pi over 3. 2 pi over 3. Pi over 3. Pi over 3. Sorry about that. It took me a little while. If we think about this as 120 degrees, and I take this number and I square it, I don't know what this xy is. But if I take that number and I square it, where am I going to end up? 240? Exactly. The length will be unchanged because the magnitude is 1. The magnitude will be 1 times 1. But the angle will be down here at 240 degrees. So here's x squared. And x to the 3rd power is right over here. So wow, it looks like I have another cube root for 1. It looks like 1 to the 3rd power is equal to 1. But I also have this other thing, this x, which is equal to the cosine of 120 degrees. I'm doing this because many of you guys aren't real comfortable, including myself sometimes, with radians. I times the sine of 120 degrees. So there's another cube root for 1. Check it out. If I take that number and square it, where do I end up? It's 240. That's 480. So 480 minus 360. If I take this number and square it, wait a minute. Is that right? 240 plus 240 minus 360? But I end up right here. And then I multiply by 240 again. I'm sorry, I add 240 degrees again. Oh, wow. I'm all the way back there at 1 more time.